Olá, seja bem-vindo às aulas de meteorologia em inglês. O que acontece? Eu acredito que para você fazer uma boa prova da Santos Dumont English Assessment, não adianta só a gente ficar fazendo aqui exames, destrinchando a prova, destrinchando a prova, destrinchando a prova. Eu vejo muitos alunos obcecados por destrinchar a prova. Tudo bem, você tem que entender muito da prova, o seu professor que você escolher para fazer a sua prova, for te ajudar a fazer isso, beleza, seja quem for te ajudar, ele vai bater em cima dessa tecla e tá certíssimo, você tem que estudar em cima da prova. Só que para você conseguir fazer, não adianta só você ficar treinando ali a prova, você tem que ter uma certa terminologia técnica. E o objetivo desses vídeos são exatamente isso. Eu vou fazer alguns vídeos de meteorologia e outras áreas futuramente, mas agora é uma sequência de meteorologia. Eu tentei fazer o mais simples possível, assim, mais focado em terminologia, acaba sendo até um pouco de revisão a respeito de meteorologia. Óbvio que eu tentei não ir muito a fundo, porque exatamente a questão é você aprender o inglês técnico ligado à aviação. E no caso aqui, eu utilizei meteorologia, até que nesse caso pode ser até utilizado por outras pessoas que queiram aprender sobre meteorologia, mas aqui é focado, em meteorologia ligada para a aviação. Vamos começar? A atmosfera, essa lindíssima foto aqui, vista do espaço. Ui! Vamos que vamos. English mode. Composition of the atmosphere. Nitrogen, oxygen, other gases. Nitrogen 78%, oxygen 21%, other gases 1%. Okay? Structure of the atmosphere. Most flying occurs in the troposphere, although high flying jets may cruise in the stratosphere. The boundary between the two regions is known as the tropopause. Tropopause, just like pause. When you pause the movie, you're watching a movie, you pause the movie, that's pause, tropopause, just like in Portuguese, all right? Boundary is the limit, like a wall, the boundary of something. Okay, let's keep going. International Standard Atmosphere, the ISA, that all pilots know. It's a reference. The standard atmosphere assumes the main sea level value to be a pressure of 1,013.25 hectopascals, a temperature of 15 degrees Celsius, and a density of 1,225 kilograms per cubic meter. All right? Try to even get those things like cubic meter as I said here. Temperature scales. A standard unit of measurement of temperature in aviation is based on Celsius scale. You might still find the reference to the Fahrenheit scale in the United States Pilot Handbook. All right. Freezing point is just a reference. All right. A freezing point is 32 degrees Fahrenheit and 0 degrees Celsius, and the boiling point is 212 degrees Fahrenheit and 100 degrees Celsius, all right? So freezing and boiling, just like on the water when you want to have a tea or something, right? Boiling. I'm going to try not to translate, all right? Just like this boiling, I did it here. Change of temperature with altitude. In ISA conditions, the temperatures fall at a constant rate. Constant rate. Eu não vou falar que rate é razão, porque eu estaria dando mole para vocês. Of 1.98 degrees Celsius per 1,000 feet up to an altitude of 36,090 feet. Alright, so ISA temperature, the formula is plus 15 degrees minus 2 times the feet in 1,000, all right? 1,000 feet. Actually, on the everyday basis, we just use 2 degrees per 1,000 feet. I'm just being precise. Transfer of heat energy. Radiation, absorption, conduction, convection, latent heat, and advection, okay? Latent heat is used to describe the heat transferred by the change in the state of a substance. When liquid water changes its state to water vapor, in Australia they like to say water vapor, latent heat is absorbed by the atmosphere. All right. Just using here just to show convection and advection. I remember I learned that convection, you get the C, turn around, so like going up and down. In advection, use the A, saying it's a horizontal movement, and convection is a vertical movement. It worked for me, so it was nice. Temperature inversion. In some layers of the actual atmosphere, however, temperature may actually increase through a relative shallow band of height. Shallow. Oh, what is shallow, Camilo? Shallow. When you go on the water, on the beach, first you go on the shallow water, just on your knee. Okay, shallow. When this happens, we refer to it as a temperature inversion. All right. Very popular in São Paulo with the smoke and everything, like the pollution. Significance of inversion. Inversions are of significance to pilot for the following reasons. The atmosphere is very stable and vertical movement of air will be resisted. Inversions may limit the vertical development of clouds. And because there will be warm air overlying the cold air, causing a reduction in the normal mixing of air with the lower level, an aircraft climbing through an inversion may experience sudden increase in wind and wake turbulence. All right, when you break the inversion, it's different. So like the temperature starts to fall again. When you have an inversion, when you're inside the inversion, climbing through it, you're gonna increase the temperature, which shouldn't be that way. Flying condition in inversion: vertical wind shear, density change, turbulence, climb performance, in cloud and visibility. All right, turbulence only when you get out of it. So that was a very short class. I'm trying to make it very short classes so it become easier. So at the end of class 1, let's go to class 2, clouds and precipitation, all right? So, vou falar um pouquinho em português agora aqui no final. Eu tentei fazer bem curtinha a aula, que exatamente em homenagem à pessoa que mais me ama nesse mundo, minha mãe, fica no meu ouvido: Camila, você está fazendo uma aula muito grande, faz uma aula pequena. Pronto, fiz uma aula bem menor. Espero que tenha sido mais didática. Pegar os termos técnicos, né? As outras aulas vão só mais a fundo a respeito de termos técnicos. Enfim, né? Espero que tenham gostado. Até a próxima aula. Tchau, tchau.